Hi there, this is Shamir here. In this video, I'm going to talk about wave. So wave is a series of vibrations or oscillations. So sound is created when something is vibrates or sending waves through the air or other materials. Hi there, this is Shamir here. In this video, I'm going to talk about wave. So wave is a series of vibrations or oscillations of traveling from one point to another point. So that means it's an energy that is carries energy without transferring matter. So here's the types of wave. Number one, that is here transverse. All right, transverse wave. If you see here, here's a diagram. So let me show you types of waves. Transverse wave. So this is the vibration of particles are perpendicular to the direction of travel. So here is a direction of travel here through and crest and wavelength and amplitude. Types of waves. Longitudinal wave, that is the vibration, so particles are parallel to the direction of travel. So this is the compression, and here is a rarefaction. So if you see here, this is the difference between direction of travel here. Longitudinal. A small drop of water on a calm water surface can create ripples. Amplitude, it's refer to the height of the wave from the center line. It tells the loudness of the sound. Amplitude. So types of wave, that is transverse wave, that is the vibrations of particles are perpendicular to the direction of travel. And longitudinal wave, that is the vibrations of particles are parallel to the direction of travel. Let's think, how could you use a slinky to demonstrate how transverse and longitudinal waves behave? Here is some examples of waves. That is, light waves ripple on a water surface and slinky moving up and down as waves. And longitudinal waves, that is sound waves, slinky move back and forth, and that is the P waves. What's the difference between transverse wave and longitudinal wave? Transverse wave, that is particles vibrate perpendicular to the direction of travel, and longitudinal wave, that is particles vibrate parallel or to the direction of travel. What's the difference between? So here's a wrap up wave, that is the vibrations or oscillations traveling in space, and transverse wave, that is perpendicular, and longitudinal wave, that is parallel. How do sounds travel? So this movement creates areas of compression where particles are closer together, and rarefaction, and where they are spread apart. That is the direction of wave travel. Sound waves and wave traces. So scientists and musicians are wave traces to analyze and compare the characteristics of sounds. These graphs show how large the vibration of air particles is over time. A device called an oscilloscope is used to display wave traces. So remember that sound waves are longitudinal waves even if wave traces show a transverse wave. So here's a no sound, that is the over time, and with sound. So wave traces vary depending on the sound being picked up by the device. So here is some characteristics of sound wave, that is the frequency. So here are the two key characteristics of sound waves are frequencies and amplitudes. So frequency, it refers to how fast the wave vibrates or the number of cycles per second. So it's measured in hertz and determines the pitch of the sound. And amplitude, it's referred to the height of the wave from the center line. So it tells the loudness of the sound. Characteristics of sound waves. So here is the frequency and pitch. So higher pitch, higher frequency means more waves and passing through a point per second and results in a higher pitch sound. And lower pitch, that means fewer waves passing through the same point per second and creates a lower pitch sound. So guys, here's a quiz. Take a look at the wave traces below. How might you compare the sounds they represent? Answer here has constant pitch and loudness and has a lower pitch than B due to lower frequencies, so has varying pitch and loudness, represents louder sound at the beginning and end, and softer sound in the middle.